Thank you for joining us. This video is to give you an overview of our technical practical workshops, what's involved. This video will show you the difference between multimeters and oscilloscopes, where you will use them. The video is high level. In the workshops themselves, you will have more opportunity to interact directly with our instructors, ask questions, and learn more about the subject. So first of all, we're going to start off by looking at multimeters. We've got a standard digital meter here with lots of buttons on it, and over here we've got an auto ranging meter. So the auto ranging is easier really because you've got your off button, you've got AC volts, DC volts in line with 3 dots, ohms, which is used to measure resistance, you have continuity tester, and you have a diode tester as well. So this is relatively easy to use. If you of course have got your probes here that you connect onto the battery or whatever you want to connect onto. On it, you have got your AC volts, just switch on your AC volts range. So it'll take a few seconds for it to come on. There's your AC volts range there. AC is a little squiggle like here. You got your little squiggle for your AC symbol here. And I'm picking up from the air there, I'm picking up about 0.23, whatever, volts at present. If I touch these probes here, it'll probably change. That's due to some AC volts in my body. It will actually change the voltage we're reading here. Measure DC volts too, like so AC first of all is usually voltage from the mains, but it can be other sources also. DC is voltage from batteries, right? But you can have DC power supplies as well and so on. So I'm picking up MV millivolts, which is small voltage reading at present here. Literally from the air, I'm not connected onto anything with these probes. Measure ohms, resistance as well. And there's also a continuity tester and a diode tester over here. So this can do lots of things, but I like this meter because if you want to measure, say, DC volts, all you do is you go into DC volts and it will pick the range for you. It's a bit like a car with an automatic transmission that it'll select the gear automatically for you. So over here then on this side, we've got the standard digital multimeter DMM. And this one, same as the digital one essentially, except you need to select the particular ranges. So DC volts over here, line with 3 dots is your DC volts. You've got different ranges here. So when you're measuring voltage, you always start in the high range and work down. So the highest range here is your 600 volts range. So that's the highest range that we can go on. So if you're measuring voltage of an unknown source, like a battery, for example, you didn't know what voltage it was, you always start in the high range and work down from there. So we'll just measure this battery here. For example, we got a Varta battery here. So it's supposed to be a 9-volt battery. So we'll see how many volts it actually is, this 9-volt battery here. Well, supposedly 9 volts. There's 9 volts written down there, 9V on this one. So we'll see how many volts it is. So we'll just get our probes again from this meter and go on here to read our volts on it. So here's the plus, this is the minus. Yes, so plus minus. Let's see what we get. So come on here, we're getting 8 volts. Okay, so 8 volts is supposed to be 9 volts, but I'm on the high range here. So if it's around 8 volts, I can actually go on the lower range. So let's go to the 200 volt range. Oh, it's 9.4 and getting more accurate reading as it's going down the ranges. Let's go to the 20 volt range and 9.57. So it's a very good battery, this one. It's supposed to be 9 volts, but I'm actually reading 9.57, which is an excellent reading indeed. So it's doing quite well. I could go to the 2 volt range. Well, I don't know if I really can, because on the 2 volt range, the maximum voltage is supposed to read as 2 volts. That's too low a range and may damage the meter. It's called OL overload here. And so the 20 volt range would be the optimum range there to read the voltage from this battery. We can go on to our digital meter here as well and use the other probes there. If we want to read the same battery there, so we'll see how we're doing on this one. So they'll probably read a little bit off, but fairly similar, but 9.64. Again, they'll always be a little bit off, but, you know, reasonably close together. And on this one then, you don't need to select the range, just go onto your DC volts range and that's it. So it's very easy to do. So you can read volts, resistance, DC volts, resistance, AC volts, amps on these. This one doesn't read amps. There's a big story to reading amps. And you'll find when doing one of our courses that reading amps is something that we don't do very often. And that's why even on this expensive, sophisticated meter, there isn't an amps range on this meter. I can measure ohms to resistance. So I'll go to the ohms range here and join our 2 leads together there. And we will get, let's see, 0 ohms should be yes, K ohms, 0.4. It's probably the resistance of the leads of the meter, 0.3, 0.4 of an ohm. That's, these are unconnected, then you'll read a 1 or OL for that, okay? Mega ohms is reading here. And let's go on this meter for ohms here, then ohms. Like maybe the 200 ohm range. You always start in the low ohms range and work up on a meter that has ohms on it. So come on here, and we're reading, it should be around 0.1 of an ohm, which is good, maybe 0.2, and it'll read OL there, whereas this one just reads millions of ohms, okay? So again, every manufacturer will have slightly different ways to display the resistance readings for you. Measure volts, so we measured this battery here, which was 9 point something volts. Let's go on to another one. Right, so this is another battery here, 9 volts again, but I'm not sure if this battery is quite as good as the first one we measured. And let's see what volts we're reading on this battery here. Oh, 8.27, so battery is not quite as good, okay? In fact, less than 9, so it's not that good at all. So here we got another battery, it's supposed to be 12 volts. Yes, this is more lead, this is a lead acid battery that you would see in use in fire alarm systems or intruder alarm systems. Plus minus here, so the red lead on plus, black onto minus, and this should read around 12 volts, 12.57, so that battery is in very good health there. So there's just a little bit on meters. There's a lot more to learn about meters. So meters will do all these things for you. If you want to, instead of using meters, you can use things called oscilloscopes. Here's a little oscilloscope here. There's different types of these. This is a little baby scope here. It's a handheld scope, and it's quite a nice scope, and you can measure AC volts, DC volts, different things on the oscilloscope there. So okay. And now we're going to look at oscilloscopes. There are two main types of oscilloscopes. Here, this is the standard scope. This is a little portable scope here, battery operated, charged through a USB connection. And you can look at various waveforms that it's quite small, as you can see, but very handy to move around. Oscilloscopes are similar to meters, except you can see a visual of what's going on, where you can't do that with a multimeter. Oscilloscopes can measure voltage, AC volts or DC volts, but they can't measure resistance or current. They're just good for measuring voltage. But one big advantage, as I say, is that you can see the display and you can see what's going on. Another type of scope then is a PC-based scope, which is this one here, which is essentially just a box is all you see. And this gets connected then into a computer. And your display then is the screen on the laptop or the desktop, whichever you want to use. This is the probe for the oscilloscope here and the earth connection for it. There's a bit to the probes too about the settings for the probes. There's a by 1 by 10 step down ranges and different things. You can measure different types of voltage with oscilloscope. You can measure DC volts like from batteries, or you can measure AC volts, which would be from the mains. Also, if you want to do that, you might have voltage step down via maybe a transformer like this transformer here. But with high voltage, you've got to be very careful. Usually voltages from about 50, 60 volts up might kill you, right? Maybe even less. So 30 volts can kill some people. So you need to be very aware of high voltages, and they may kill you very easily. So I'll just show you the output from this scope. If I can now, just try and share screen with you there so you can see what's what. We'll just start onto the oscilloscope here now on the desktop that I've here. I'm going to go to picoscope. There's a picoscope. There's lots of different types of PC-based scopes available. This is just one type that we have, and we find it quite good, but there's lots of different ones available also. Okay, so we're just going to have this on here. So we're not running at the moment there, so I need to plug in the scopes. Just going to plug it in there now. Come on for us then. So just on via USB connection. We should be connecting onto it now at present, okay? And we're showing there an AC volts coming in. Yes, AC. It's up and down and up and down and up and down. So AC means changing. So here in the center of the screen, you've got 0 volts, 0. You go positive and you go negative. So I'm going up here by about 0.8 of a volt up and 0.8 of a volt down. So trigger none. So I'm going to put a trigger on there. Hopefully this should stop all the jumping around. So we've got a fairly beautiful sine wave up and down there, running up and down for us. Okay, so we also have that. We'll just jump back for a second now. We also have that on the other scope that we have, standard small portable scope. We have our sine waves here, except that it is not very synchronized. We've up and down, we see different things, but we need to do some adjustments to make this a bit better. So to do that, you have a voltage up and down with these two arrows here, and you have the time up and down here. Time is in seconds to do with oscilloscopes and electronics and so on. So we're just going to try and adjust this to make it be a little bit better, if at all possible. So we just see if we can get, oh, we're speeding up a little bit, yes. So our time here on top is milliseconds, 200 milliseconds. So I'm just going to change that a little bit. Now, we got all the waveforms in here, but the problem with them is that they are so close together that it's just difficult for me to see them. So I'm looking at an AC waveform at the moment. We're looking at the mains after being stepped down via transformer. So we should see about 50 times per second, all going well. Oh, there you go, 50 Hz hertz coming up there. So we got it adjusted fairly well now. So we're fitting into the screen here. And the screen here, we go from 0 volts up, positive voltage, 0, negative voltage, which is a positive, then going the opposite way. So it's telling us here VPP, volts peak to peak, around 32 volts. So that's from there to there, would be roughly 32 volts. So we're in 10 volts per box. So this box is 10 volts. This one is 10 volts. That one's 10, but we're using about half of that, say 5. But about half of this, which is 5. So 10 and 10 is 20. And 5 and 5 is 10. Another 10, 30. Yes, a little over 30. There's your 32.2 volts. Yes. So we're running up and down a little bit here. It's varying up and down because the mains voltage varies up and down all day long, and in relation to different items being plugged in a house or business premises or locally, around the area. The voltage from the power supply company can vary up and down, and 50 hertz, 50 cycles per second hertz, that will be different in America. That will be coming in at 60 hertz in America. So that's fine. So we'll just go back to our other scope. Then we're going to go back and look at this one here and see how that's looking on the computer. So I'm just going to share the screen here again, try and get our computer screen up there. So we come up we go, yes. So there you go, you got it there, okay? So we're going to have a look. So now it is showing AC because it's changing up and down, but we don't have a very nice picture of it. So we're just going to change the time here, 20 microseconds per division. Going to change that a little bit and see, going to go to 100 and see what happens. We've got it there. Yes, we've got our cycles per second going up there, except there's an awful lot. It might go trigger here, auto. That should stop it from wandering around the place. So we've got all our cycles per second here, but there's a lot of them there, right? So just to make it a little bit more visible, then I might go on to 20 milliseconds here, and there you go, yes. So a cycle there, when you go from 0, up positive, down to 0, negative, back there, that's one cycle. So in the cycle in Ireland, for the mains voltage in Ireland and in Europe, we should have 50 cycles per second. So here on the bottom here, you've got the time is in milliseconds. So we're going all the way here on the right side up to 100. We're going to 0, and we're going to minus 100, which is 200 in total. So I'm just going to change time of this for a minute there and see how we do. Yes, so we're just going to change time. And actually going to put this up to 100 there and see how we do. Yes. Okay, so that's 100 there. You're just going to press stop on this. Well, we don't need to, it's an auto. So we're up here to time minus 0.5 of a second up to 0 plus 0.5. So all of this here, from one side to the other, is 1 second, right? So in 1 second, we should have, according to our other scope here, yes, this one, we should have 50 Hz, 50 cycles per second. So what we're going to do now is we're going to go back there and going to see, do we have the 50 cycles per second or not? So we'll just count from the peaks there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We got at least 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. There's your 50 cycles per second, or 50 hertz, which is quite amazing. You can also get the oscilloscope to measure DC voltage if you want to. So what I'm going to do is I'm just going to get the connection from it, and I'm going to connect on to, going to get the connection here. I'm just going to connect that onto a battery. Yes, so we just put it onto a battery and see what happens. So we're going to connect and get the right connection for this here now if we can. We're going to connect onto a battery and see what volts we're going to get from it. So we're going to go onto this battery here, going to go negative. This should be around 12 volts, like we said before, around 12 volt battery there. So one here positive, right? And we'll see if we get our voltage reading correctly. So we're going to go back now and share the screen with you again and see what's on the screen there. Okay, so let's come on here now. Things are not going too well. It says channel overage here at present. So we're on the 5 volt, 10 volt. We'll go auto here. So I'm going to go off of auto for a minute. I'm going to go onto the 2 volt range. So we've got 2 volts up here and channel overage because we're looking at 12 volts. And we're giving it around the 2 volt range. So this is an unhappy oscilloscope at present. So we're going to change here to the 5 volt range. 5. Not going too well on 5. Let's change a bit higher. Let's go on to 10. Not too well on 10 because our battery voltage is 20 volts, or it's 12 volts. So we go on to 20. And hopefully that should work. Yes, slightly above 12 there. There you go. There's your DC volts. Just going to disconnect the battery now. Disconnect it, should drop down to 0 volts. Yes. And back up again. So the advantage of the scope is that you can see electrical noise on it. You can see exactly the line you have, and you can see all these little bumps here is electrical noise. That is noise from motor car ignition systems, from Wi-Fi, from music systems, from mobile phones, and so on. Okay, so that is your oscilloscope there. Let's have a look on the small scope if we can. So we just stop the screen share on that one. So stop that there. So let's go back to our small little scope here. It's looking at an AC signal there at the moment. So we look at, let's look at a little battery like this one here. So we're going to get the connections for this, put it onto the battery. So we're going to go on to the minus here on this. We're going to go on to the plus on this one. Yeah, so hopefully it'll stay on there for us now. And we got a line there. Yes, there's your line there. This battery we said was a little bit less than 9 volts. So your reading. So your 10 volts for every box is we just fell off there. Now let's just put this back on again. Every box is 10 volts, so we're reading a little bit less than 10 volts there. If you wanted, you could change that to a different value per box if you can. You see, it doesn't seem to want to do that for us now at the moment, so we're stuck on auto, so we'll just leave it on that. So you're just less than the 10 volt box there. If you want, you can get your battery and turn the terminals around on it. Let's go on here, this one, put your positive, put your negative there, positive here, yes, swap around, and you go minus 10, or well, about minus 8 on this one, because our battery is running at around 8 volts. Okay, so that's a nice little scope there. Yes, if you wanted to use that one, you can put an auto set on it as well, and it should automatically set up for itself. So here, when we went to auto set, it has just automatically set up for us, and 0 hertz, because you have 0 hertz with DC voltages. Okay, so that will give you a bit of an idea about oscilloscopes. There's a lot more to all these, and knowing when to use them and what to use them for. Okay, so we'll just go back on our screen then back to where we are. So thank you very much for joining. Hopefully you found the video useful, and we look forward to meeting you on the workshops. You can contact us through our website, hightechtraining.ie, or our email, admin@hightechtraining.ie, or through social media. So again, thanks for your time.